Everyone, my name is Thomas Kim. Today is June 29th, 2022. This is my 16th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL TBB. This is second video about TBB internals. I would introduce pair dice. Also, using divide by conquer programming pattern, we will implement parallel search. I created this example to explain task group. I will not explain about task group in the future sessions. I would recommend this link for documentation about task group. Task group has member function run. Also, cancel. We'll be using run, cancel, and wait member function or run and wait member function. Because task group is very simple class, I would not explain about task group in the future session again. Also, we need pair dice for this example. C++ library extensions, please double-click this link. I updated this library June 28, 2022. If you haven't installed or updated to the latest version of C++ library extensions, please double-click this link to download the source code. You have to update your installation. Also, I assume you have watched my previous videos. By clicking this link, you can open the playlist. I assume you have watched my previous videos listed here in sequential order. Otherwise, you may not understand my current and future sessions. I am confident that I have gained enough experience with CUDA SQL and some with Intel TBB. If you do not miss my videos and try my source code by yourself on your own machine, you will eventually understand how to use CUDA SQL and Intel TBB. All the misfortune arises out of misconception or misunderstanding. In this PDF, Ctrl F, search, not free. So, in chapter 2, I would copy this text for your reference. Spawning and scheduling a TBB task is not free. A rule of thumb is that a task should execute at least 1 microsecond or 10,000 processor cycles in order to mitigate the overheads associated with the task creation and scheduling. We will provide experiments that demonstrate and justify this rule of thumb in more detail, chapter 16. Please don't forget that our task should execute at least 1 microsecond or 10,000 processor cycles. This 1 microsecond or 10,000 processor cycle can be dependent on your hardware device, so you need to gain some experience. Also, in this episode, we will learn chapter 10 using tasks to create our own algorithm. I would highly recommend you to read this part of the book. Here, task group is explained, so I would highly recommend you to read this part of the book. Also, in Chapter 15, Cancellation and Exception Handling, you can find more information. In this case, we are using task group context. Don't get confused with task group and task group context. They are totally different entities. Without further ado, let's get started. Start your Visual Studio Code. Open your working folder. Select empty space. Click this button. 016 Task Group. Click this button. Task Group. .cpp. Hit Enter. Ctrl V. Include talkplay fun output HPP. Include talkplay fun chrono random. We need chrono random for pair dice. Name space TCR talkplay fun chrono random. Please remember namespace alias TCR for talkplay fun chrono random because we will be using this namespace alias all the time in the future sessions. Talkplay fun stream print auto NL talkplay fun NL auto NL talkplay fun NL void test pair dice. Int main copy the function test pair dice, paste it here. Int n, for example 6, auto pair dice TCR pair dice. Int means we are generating integer numbers. The first comes lower bound. The second comes upper bound. We are generating from 1 up to 7. 1 is included. 7 is not included in the range. std vector int container we allocate n. std generate container begin container end. Pair dice. It does not work. Please understand that it does not work. Pair dice cannot be copied. Instead, we have to pass as reference std ref. We have to wrap pair dice with std ref. Now print container and open up this pretty bird. cd 016 task group clehsc std C++17 task group.cpp fe m.exe hit enter. 16. Sorry, we build again. CLSM. So from 1 up to 7, 7 is not included. So 6 numbers 1, 2, 3, 4, 5, 6. These are paired dice. Now we will make it 12. We build again. CLSM. Please understand that two twos, 1, 1, 2 ones, 4, 4, 2 fours, 3, 3, 2 threes. This pair dice generates pair random numbers. I hope you understand what pair dice means. For example, if from 1 to 13, then we are generating from 1, 13. 13 is not included in the range. We rebuild CLSM. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4 is repeated twice. Let's move on. Now I will fold it up. Here, using namespace SED chrono retrials, we need to declare chrono retrials or overhead. This is 1 microsecond. 1 microsecond. Void search serial SED vector int const L value reference container int result. This is return value index. Int value to search. Int begin, int end. For or I equals begin, I not equal to end, plus I SED. This thread sleep for overhead 1 microsecond. We simulate our real application. If container I equals value, result will be index I, then return. This is serial search. Of course, there are more efficient search algorithms. This is just for experiment with parallel algorithm. Now, I will copy this, paste. Here, TBB task group, L value reference group, like this. I will give a line break here. Once we get our result group, this group is our task group. Cancel. Please note that we are inside the loop, so by returning, we exit this function. Once we found the value, we cancel our work group. Now, here, template int cut off void search parallel std vector int constant L value reference container. We are using std atomic int L value reference result. The reason we have to use atomic is that we are executing this function with multiple instances simultaneously. So we need atomic here. We cannot pass atomic by value, but we can pass atomic by reference. Then int value, int begin, int end. We create TBB task group. Before we exit this function, group wait int size end minus begin. If size less than cut off, then we are calling such serial like this. We pass group container result. It should be std atomic int. Scroll down, value begin end. Else int middle begin plus end minus begin half. This is actually equivalent to begin plus end over 2. These two are actually equivalent. Or such lower, we just capture all, don't forget semicolon. We are calling this function recursively. We have to pass cut off here. Then container result value begin, then middle. Copy once again, paste. This is search upper. Then it should be middle end. So from begin to middle, middle to end, we divided into two segments. So this is divide by conquer programming pattern. Here, group run, search lower, copy, paste, search upper. Then it falls down here. We have to wait. Now, void test parallel search. context for int cut off. We would set 10. int n 1000. int value n over 3. Value can range. Here I forgot one thing. Auto pair dice. TCR pair dice. int we will start with 0 n. So we are basically generating numbers from 0 n. n is not included in the generated dice phase. std vector int container n. std generate container begin container end. Then std ref pair dice print container and please understand that print is a memory buffer. This print cannot grow indefinitely. So if n less than, for example, 100, then we print out. Initially, we will start with 100 or less than 100. We will test if it builds successfully. Copy, paste. Now disable it. We rebuild CLS-M. So we generated random numbers. int serial result std atomic int parallel result auto t0 TBB tick count. Now we call this search serial function. We are not calling this function. We are calling this function. Scroll down. Paste it here. We pass container. Then serial result. Then value. We are searching this value. Then 0 n. So n is 100. Container element size auto T1 TBB tick count. Now print serial search result. Because we passed serial result here, NL also auto serial elapsed T1 minus T0 seconds. Now copy this, paste it here. It should be T2, T3. This is such parallel. We have to pass parallel result. Then parallel elapsed T3, T2. This is parallel search result. Parallel result. Print serial elapsed. Serial elapsed seconds. And copy paste. Parallel elapsed. This should be parallel elapsed. Copy paste. This is serial parallel. I will fix like this. Serial elapsed over parallel elapsed. Go up. This is such a parallel. Container atomic value begin end. Container. Then what comes next? Result. Then value begin end. What's wrong? Let's build. Then sorry, we have to pass this cut off here. Don't forget this. Here we have to use AND L. We have to flush out to console. Now we rebuild CLS M. So serial search result 60. Parallel search result 60. Serial search result, parallel search result, they should match. Then serial elapsed time 0.41 second. Parallel elapsed time 0.12 seconds. So parallel algorithm is approximately 3 times faster. We can try again. Now 4.5 times faster. 1.2 times. We can make it 1000. Also, we can increase our overhead or workload. Please understand that it can be understood as workload, or I would say payload. I changed my mind. Payload is the proper expression in this context. Now CLS rebuild, CLS-M. So serial elapsed 15 seconds, parallel elapsed 0.9 seconds. Parallel algorithm is much faster than serial or sequential algorithm. But don't be misguided about this result. If the payload is 0, then the result can be different. CLS-M. Now serial is much faster, so depending on payload, the result can be different. I would set it back 10 microseconds. This is our final result. M. Once again, M. So, in the given conditions, parallel algorithm is approximately 10 times faster than sequential or serial algorithm. At the beginning part of this episode, I explained about this part. Spawning, scheduling a TBB task is not free. A rule of thumb is that a task should execute for at least 1 microsecond or 10,000 processor cycles. Don't forget this fact.